In this video, I'm going to explain ellipses, and it's in my book, Ellen's Guide to Perspective, on Amazon. I'm going to compare ellipses with ovals. So an ellipse has two axes that are unequal, otherwise it would be a circle. The major axis is the line spanning its greatest dimension, while the minor axis travels through the center and is always perpendicular to the major axis. The ellipse is symmetrical around both axes, so the top and the bottom are mirror images, as are the sides. The two axes can vary in an infinite number of ways. When they're almost equal, the ellipse is a circle. When the minor axis shrinks, the ellipse approaches a line. And ellipses curve continuously, so avoid flat shapes like a cigar or pointy ends like a lemon. Don't do either one of these. An ellipse usually represents a circle in perspective, that is, from any other viewpoint except parallel to the picture plane, which we'll discuss. It usually doesn't represent a truly elliptical 3D shape since they're rare. Maybe the closest is a blimp or a watermelon, but for the most part, it represents a circle in perspective. Now, an oval is a shape that resembles an ellipse, but looks more like an egg. And unlike an ellipse, it doesn't have a precise mathematical definition because it can be made in many different ways. It's composed usually of half an ellipse connected to half a circle, or two different ellipses combined, where they share the minor axis. So as a result, they aren't symmetrical around their minor axes. What is the center of vision? Well, it's exactly what it sounds like. It's the center of our line of sight. So if we're looking straight ahead here, and this is the picture plane or the paper or the window, this would be the center of vision, the intersection of eye level, which is the position of our eye in space, and the central vertical line. The opening of a cup looks like a circle only if two things are true. One, if the center of the cup is at our center of vision, meaning we're looking directly at the middle of the cup. And secondly, the circle is on a plane perpendicular to our line of sight. So here we have a cup and we're looking down at it. It looks like a circle. And think of the circle as having a horizontal axis that's eye level and a vertical axis that is the central vertical line. Since we can only have one center of vision in our picture, that means we can only have one circle. So this coffee cup is a circular opening, meaning that the center of vision is in its center, and it has the true horizontal and vertical lines. Now this coffee cup is elliptical, and one of its axes is pointing toward the CV, but as I will tell you in the next video, it's actually pointing toward the nadir, which is below the center of vision. I'm going to manipulate this coffee cup to show you all the wonderful things that ellipses can do. So this ellipse starts out pretty narrow with a small minor axis. And when we lower it, so we're looking more into the cup, the minor axis gets larger and the ellipse gets larger, whereas the major axis doesn't change much. When the cup is further away, both axes change, and I'll go into how they change in the next slide. If you tilt the cup toward us, this minor axis changes a lot, and if you tilt it enough, this coffee cup will look like a circle. And then lastly, you can tilt the major axis, and that tilts the ellipse. There are a few situations where we can see both a circle and an ellipse. So let's say that this is a pattern on a bracelet, and if we look directly at it, we will see a circle in front and an ellipse on the side. Now remember Slinkys, those spring-like things that walk downstairs? Well, they can look like circles or ellipses or even lines at some point. And if you flip a coin, it can look like a circle, an ellipse, or a line. Now, when the minor axis decreases more than the major axis, the ellipse appears to recede toward eye level. And we only see ellipses in this case. We don't see circles. When the major axis of the ellipse tilts, then the whole ellipse tilts. An ellipse looks like a line at eye level, which is located just above this photo. So let's say that this is eye level. The yellow vase is taller than the rest, so its ellipse is pushed vertically up close to eye level, and it narrows quickly because the vertical direction is the shortest path to eye level. When the two smiling flower pot men, I never thought I'd say those words, recede in the distance, the ellipses follow a diagonal direction toward depth, and these ellipses narrow more gradually since they follow a longer diagonal course toward eye level. Now this flower pot seems to be tilted toward us because its ellipse is much wider than the others, and this is due to lens distortion since they're all on level ground. Where is the center of vision in this photo of a pineapple? Since I didn't crop the picture, it's where the two diagonals cross. It's the center of the photo. So this would be the center of vision. And it is the roundest of whatever these things are called on the pineapples. Now the yellow axes become more horizontal as they approach the center of vision, whereas these green axes become more vertical as they approach the center of vision. And you can imagine these green axes pointing toward the center of the form. This flower is the roundest, so our center of vision must be in the middle. And you can see that the flowers on the side are narrower and tilt upward. Here we have a pattern on a cup, and this is the roundest part of it. So our center of vision is right here. And you can see as the ellipses go toward the distance, they narrow and they tilt up. In my next video, I'll describe more how ellipses tilt, and please remember to subscribe.